See, my equation is 4.4 I1 minus 4 I2 is equals to 24. This is my first simultaneous equation, and my second simultaneous equation is minus 4I1 plus 4.25 I2 is equals to minus 20. Can you just tell me the value for currents here?
Ma'am, I1 is 8.14.
8.14.
Then
I2 is
2.96.
I2 is 2.96.
It is 8.14, right?
Yes, ma'am.
Yes,
Then
ma'am.
2.96.
2.96.
I2 is 2.96.
2.96.
2.96. Okay, one second. Yeah, 8.14 and 2.96, the current. Now, can you just tell me the voltage across the load? Load means one second. See, someone asked me this particular question because I don't know the name of that person. I'm just getting it is 8.1 amperes and 2.96 amperes. So, see, I have shared you some exercise problems to you in the textbook. Like there, it consists of 8 questions, and even they have given the answers there. They have given the answers. Yes, you can remember that. No, I think I have given that questions in the last week. So in that particular question, one of the student, I will just go through who is that, I don't know. Just it is mentioned as Sai here. I don't know who is that person. Someone has given me the question of fifth question. You have shared me your answer, and you have asked me, we are not getting the exact answer what exactly it is given in the textbook. May I know who is that?
Yes, ma'am.
Who is that?
I'm Sai Prakash.
Sai Prakash. Okay. See, Sai Prakash, I'm getting the same answer here. It is 8.14 amperes and 2.96 amperes.
I got a negative sign in that 2.96.
That's what I have. I have written the problem in the particular book. I will be sharing through WhatsApp. Okay, I will be sharing you through the WhatsApp. Please go through that and analyze where exactly you have made a mistake there. When you are considering the current direction only, you made a mistake there. Considering the current, and when you are applying the loop, KVL loop, whenever you move from positive to negative, it should be considered as negative sign. And when you are moving from negative to positive, it should be considered as a positive sign. You made a mistake there. Just have a look of that. I'll be sharing you the solved problem through WhatsApp.
Okay, thank you, ma'am.
If even others want that particular problems to be particular problem to be shared, I will share. I will just put the question number, that is exercise problem number 5. So I have written it is problem number 5, and I'll be sharing in the normal group itself, in your class group. Please make sure that whether you are getting the same answers there. Getting my point? So you can go through that. Even I'll be sharing in this B section. Yeah. I have shared even in the B section. That is the solution for fifth question. That is a solution, and it is only a first half. That is I1 and I2. And using that I1 and I2, you can calculate the voltage as I already discussed. Okay. So this is a solution where I don't have a scientific calculator. For the same reason, I was waiting for the answer. I should come back to few person, I should interact one or two for solving the simultaneous equation. So let me solve it in the class. I did that. Okay. So moving further, in the previous class, I was discussing about the RMS value, average value, form factor, peak factor, and a few problems based on that, right? So today we are going to study about today we are going to study about if we are considering two or more what is that, conductors. So previously we used to do it for only one single conductor. Now suppose I have conductors. Conductor means it is a current carrying device, or you can also have more wires. Okay, I have, instead of one wire, I will be considering two wires or three wires. Or in turn, I can speak it as, instead of speaking with a single phase, I'll be speaking about a three-phase system. Three-phase system means I'll be having three wires, and all the three wires, it will be consisting of different voltage and current parameter, right? So instead of that, I will just take three wires, and all the three wires, it is connected to some kind of what is that, power, whether it may be a AC component or it may be a DC component. Okay, I'll be considering both AC and DC component together. AC and DC component together, one second. Okay, AC and DC component together. And when I consider one particular thing, it is with the AC component, and the other one, it is with the DC component. Wow, how we are going to find out the total RMS value? So till now we have considered the RMS value for only one wire, for one particular conductor. Okay, now if bunch of conductors are connected, and if you want to calculate the RMS value for that, how exactly you're going to calculate? That is what you're going to study here. See, the topic is RMS value of combined waveforms. Combined waveforms. Okay, so here what I will do is, I am going to consider a wire. I will just consider one wire, and this wire, which will be carrying more than one alternating current. More than one alternating current means the current, it can be of DC type or it may be a AC type. I will be passing the current across this wire. Once I will pass AC, once I will pass DC, once I will pass one more the other what is that, magnitude of some other AC systems. So if I'm giving the different magnitude, and the different frequency, I'll be varying the frequency and I will be varying the magnitude. Magnitude is nothing but the current. I may give for first time I will give the current for that particular conductor as 1 ampere. Next I will give 10 amperes. The 10 amperes, it may be of a DC type, that is direct current. The next I will give 20 amperes, which is of alternating current, AC type. So if I am giving different what is that, alternating currents of different magnitude and frequency, uh, and even with a different what is that, a certain amount of DC circuit, DC current also, if it is subjected. Now, and how we are going to find out, how we are going to calculate the total RMS? Total RMS is nothing but your resultant RMS value. Resultant RMS value are going to find out. See, here is one particular diagram. Here is one particular diagram. This is my wire. This is my wire. Okay. And this wire, the direction they have shown with the arrow marker means, from this particular junction, I'm passing my current. I'm passing my current. Initially, I will take my first current as it is a DC current. I will give the current I1 is equals to IDC. That is a direct current I will be giving through this wire. Okay. The second instant, I'm going to give my alternating current. That I2, I will indicate that I2 is nothing but Im2 into sine omega 1 into T. Because why it is omega 1 omega 2 is, as I told you, I will be giving a different magnitude and different frequency. Even the magnitude and frequency both are different means I can't give a general word as omega here. The frequency, if it is varying, means it will be varying as the time passes. Now omega 1 omega 2 omega 3 so on. So this is my alternating quantity. The first quantity I have given the DC component, the second I have given the AC component, and again the third component I'm going to give it as a AC component, again with a different magnitude and frequency. When I start giving all the current across this, okay, when I start giving the current across this, now what happens? I should find out. I should find out across this wire what is my resultant RMS value of current. I should find out IRMS now. If I want to find out IRMS, see, the current, if it is a DC system, I'm going to get a constant output. As the time variation takes place, now I'm going to get a constant output I1. And here I'm giving I2 with some sign variation, with some sign variations. And here I'm giving some omega T2 plus pi I have given. Just remember this pi I'm going to explain in the next concept. That is your phase angle. Okay, this is your phase angle I'm going to explain. So apart from the frequency and time period, we have added some more phase angle. Some more phase angle where my waveform it is shifted to this particular length. Okay, and I am giving this particular wave also to the what is that particular wire. Now you have to find out. I'm giving different instance of current, different instant of current. Now you should find out the resultant RMS value of the current at the time t is equals to some seconds, and I'm going to consider the resistance. The resistance of the entire wire I'm going to consider it as capital R. Okay. Now, as you know that how this RMS value of current it is induced in the circuit, how this RMS value is induced in the circuit. As you know that the RMS value always it will be induced in the circuit just because of flow of current in the conductor. When the flow of current it is taking place in the conductor, the heat production takes place. The generation of heat it is going to take place. When the heat produced, when the heat is produced, and that heat produced gives the resultant of whatever the amount of current it is flowing. So always we are going to measure the RMS value of current based on the heat that is produced inside that particular conductor, right? So you know the equation for heat produced. See, I will just consider the internal resistance of the wire is R, and I'm going to calculate IRMS. Now, suppose if I'm considering what is the amount of heat produced, heat produced. So what is the amount of heat produced total overall? Okay, when I pass all the three currents, and what is the amount of overall heat produced, if you calculate, then you can easily calculate the RMS value of current, the resultant RMS value. Now for calculating the heat produced by the resultant, it is given by a formula. It is I square RMS into the internal resistance with variation of time. As the time passes, even the heat production, it will be based on the current and the resistance value. Yes, so this formula it is known to you. Now what I will do, this is my total heat produced across the entire wire. Now I am going to calculate what is the amount of individual heat production. How the heat will be produced? Just because of movement of charges. Movement of charges is nothing but it is a flow of current. So I will take my first H1. H1 is nothing but whenever I am giving a DC component. Whenever I am giving a DC component. See, I'm giving this component. If I give this component, I1 is equals to IDC. So my equation, the heat produced whenever I'm giving a DC component for the first time. So H1 I will indicate the heat produced of a DC component. So that will be equal to I square DC into R into T. The resistance of the wire, it is not going to change whether you are giving a AC or DC component. Resistance retains same. And even the time period I can vary from 0 to some time period. The time also it will be variable and it will be same throughout, right? So my heat production of whenever you are giving the DC component, the heat produced will be equal to I square DC into RT. I will write down this. And the next time, what is the way, what is the kind of input current I'm giving here? This is alternating one. This is alternating one. So alternating current I'm giving. So what is the amount of heat produced if I give the first AC component? They have used, why it is first means I have used two more, it is of AC components only. The second current and the third current, both it is of AC. So I have used the heat produced by the first AC component. I can write it as whenever we speak about AC, always the current it will be measured in terms of RMS value, right? So the heat produced, the heat is produced just because of the movement of charges with having a conductor which is having an internal resistance and with respect to the time period. So I can write it as I square RMS2 into R into T. What is that RMS value? IRMS is nothing but Im by root 2. I will just substitute as IRMS is nothing but Im by root 2. When I substitute this and when I put a square here, so all the parameters it is going to, what are the parameters it is going to cancel here? So Im square it will be divided by root 2. So no need to simplify, just keep it as it is. Keep it as it is, and further we are going to simplify. Even if you simplify here, no, the current it will come here and this 2 and root 2 will be cancelled. So I'm going to get Im square divided by 2 into RT. Okay, even if you write that, no issues. And the third time I'm passing the current as again the alternating current, that is AC component I'm passing through this conductor, and the heat generation it is H3, and this is my equation. IRMS3 square into R into T. IRMS is nothing but Im by root 2. Im by root 2. This it is known to you. Okay. Always IRMS it will be indicated as maximum current divided by root 2. Now I have got the heat production of different current parameters. Okay, individually I got. Now what is that? If I want to find out the total RMS current, then you should find out the total heat produced in that particular wire. So how you are going to find out the total heat produced? See, here is the formula. The total heat produced I have indicated as H. H is nothing but heat produced for the DC component, heat produced for the first AC component, and heat produced for the second AC component. I'll add up all the things and I'm going to simplify. If I simplify, you can make things here. Okay, you can make things here. Whichever the common term you wanted to take, you take it out. If it is able to cancel it. You can do that. See, RT, it is common. It is present even in the LHS and RHS. You can take a common outside R and T, the resistance and the time. You can cancel. So final equation for IRMS is nothing but it is square root of D into C. So this particular thing might be, it may not be used more, but if n number of current equations are given, or if the total instantaneous current, it is having a summation of 3 or more currents together, then easily you can add up all the RMS value. You can add up all the RMS value, just finding out the individual RMS value, just add it simultaneously. So finally you're going to get the total RMS value of that particular component. So to explain this particular concept, we have one particular what is the problem here. Please take down this. Please take down this problem and try to solve that. That is 2.9.1. Take down a problem. See, in the problem it says that an AC current is given by I is equals to, since previously you used to have only one current equation, that is instantaneous current I is equals to 10 sin omega t. You have studied till here. Okay, now combined, that is, you apart from one component of current, you have two more components. So this is one component, this is component. Means you have a single wire, and for the same wire we are giving different currents. And as they have given in a problem, it is all are AC currents only. That is all the currents whatever they have given here in the problem, it is a AC component. Okay, so my equation is I, the instantaneous current. I is nothing but 10 sin omega t plus 3 into sin omega t plus 2 into sin omega 2 into sin 5 times of omega t. Find the RMS value of current. Now you should find the total RMS value of current. Okay, now how do you calculate it? How do you calculate it? How do you calculate it? You're supposed to calculate here. They have not given the time, they have not given the resistance, right? So nothing is given, you just wanted to calculate the total RMS value of current.
Ma'am, we can use IRMS is equals to under root of I square DC plus IM to root 2.
I square DC by,
Ma'am, this formula, the one which we are able to see.
okay. Now just calculate and can you tell me the value? Calculator, because just now I have explained you the concept now. I have given one problem and you tell me the value for IRMS now. You just tell me the value for IRMS. If you use this formula, do you have any DC current here? DC component in your problem?
Instead of DC, we can use IM1 root 2.
No. Don't change any formulas here. Do not change any formula. Hello?
Ma'am, it is 56.46, ma'am. Hello, ma'am.
Yeah. I got an urgent call there. Okay. Now, in this particular problem, I'm just asking, do you have any DC component? Do you
No,
have any
ma'am.
DC component? No.
No,
If
ma'am.
no DC component means I can take wherever I have IDC, I will directly take it as 0. You can give there. For the given example, there is no DC component, hence IDC is equals to 0. IDC is equals to 0. Now coming back to this, you have only two alternating AC components here, but in your problem they have three alternating components. So just add one more here. That is plus IM4 divided by root 2 whole square. For the same formula, you add one more component here. That is IM4 divided by root 2 to the power whole square. Okay. Now, if you want to solve this particular problem, you should calculate IM now. IM is the major thing. As they have not given the resistance, as they have not given the
Ma'am,
time
the
period.
answer is 7.51, ma'am.
Yeah, 7.51. So, if you want to calculate the total IRMS, my formula is, it is a square root of IDC whole square, okay, plus IM, okay, IM2 divided by root 2 you have, IM2 divided by root 2 the whole square, and so on it will be continuing. So for IM3 and IM4, the two more it will be continuing. Now this IDC I don't have, so this tends to 0. Now you should calculate IM2 here. What is that IM2? Your equation, the instantaneous equation is given as it is 10 sine omega t. 10 sine omega t. Okay. If you have 10 sine omega t, and this is my first component of what is that current, and the second component of current is, it is 3 sine omega into 3 sine 3 omega t. 3 sine 3 omega t, and the next component is, it is 2 sine 5 omega t. 2 sine 5 omega t. I'm not able to write. I don't know what is the problem. 2 sine 5 omega t. So this is the equation. Now this IM, whatever you need to calculate IM, no, this IM you should calculate for the first component. What is IM here? If I change this to a standard formula, it is I is equals to IM sine omega t. So in place of IM, I have 10 here. So I can put it as 10 divided by root 2 whole square. And what is the second component? Second component is, I should find out IM3 whole square divided by root 2. What do you have in place of IM here? You have 3. You
3.
have 3. 3 divided by root 2 is nothing but 3 divided by root 2 the whole square. And the next third component is 2 divided by root 2 the whole square. So when I substitute IM is equals to 10, IM is equals to 3, and IM is equals to 2 in the above equation, and I am considering IDC is equals to 0, then I am going to get the total RMS current is 7.516.
Yes, ma'am.
7.516. Are you getting this answer? 7.516
Yes, ma'am.
amperes?
Yes, ma'am.
Yes, sir.
Yes, ma'am.
But here they're asking you, see, within 2 steps, you have done and you have explained me. But if it is asked for 6 marks or 8 marks, how you are going to solve? So this is a combined equation for RMS value, no? So blindly go with this. So this is the resultant. It will be same only. So what is that they have done? They have considered the resistance R is a resistance, T is a time period, and you know that the RMS value always it will be generated. Always it will be obtained just by having the heat generation across the wire. So the total heat is nothing but the DC component heat plus AC component heat. Okay, and you have a formula for this. Just substitute here. Just substitute, and initially you find out the value initially for the current separately, IRMS1, IRMS2, IRMS3. Okay, and if you obtain all the IRMS value, all in addition, if you add up all these currents and if you take a square root, you put it in the formula and you're going to find out. See, you may get the answer in 2 lines, but if they ask for a more marks, you should know what are the points, what are the formulas it should be shown here. See, if you see this particular concept from top to bottom, can't we understand that this is a combined RMS value? So each and every formula it is given. You know they have given combined RMS value that is what is that heat across the total conducting wire. H is nothing but HDC. You have given formula, and what is the individual formula for H is you have given, and you have used the formula whichever you have derived now, and finally you have calculated the individual values of RMS value of current, and finally the total RMS value of current. So based on the marks they are asking, you are going to elaborate the answer. If they are asking for 2 marks, then you can go with the thing here like this. If it is asked for 2 or 3 marks, if it is asked for 4 to 5 marks or 6 marks, obviously you have to show step by step. Okay, this is a concept of the combined RMS value. Okay, RMS value, calculating the RMS value for a combined waveform. Okay, then next, I think you don't have any doubt with the RMS average, any of the concept till now. Okay, now we will move forward. The next topic is phasor representation of alternating quantity. Okay, phasor representation. What do you mean by phase? Why these phases are required? See, just now I have told you I can consider 3 currents or 4 currents, or even I can consider 3 or 4 wires which will be connected in a fashion, whether it may be a single phase or a three-phase system. If it is a three-phase system, I'll be having 3 wires R, Y, B, and if I'm using a AC component and if I'm using more than 1 wire, then obviously we have to concentrate on the phase angle. We have to concentrate on the phase angle. Like if my first wire, what is the phase angle it is maintaining? What is the second one? What is the third one? Whether we have a balanced load condition or we have a unbalanced load condition, all these matters comes into picture. If for understanding that particular point, you should know what you mean by phasor representation. Phasor representation means, see, till now you used to measure the voltage or current in terms of sinusoidal waveform. Okay, as the time passes, I'm going to get some amount of current or some amount of voltage. I will trace the entire thing, and if I join all the dots, I'm going to get a purely sinusoidal waveform. But how we are going to convert that sinusoidal waveform into a graphical representation? If I want to obtain graphically, means I am varying the sinusoidal parameter for any given alternating quantity. For any given alternating quantity, I am varying my component sinusoidally. I am going to get the graphical representation in the straight line. I am going to get a graphical representation. Okay, and whatever is alternating quantity which is varying with the sinusoidally, obtaining the sinusoidal waveform into the graphical representation is nothing but my phasor representation. It is nothing but my phasor representation. See, here is some of the theory, whatever I'm going to explain now. The same theory they have given here. I'll just quickly go with the diagram. See, the same theory I'm going to explain now. Okay. Once seeing this diagram, I'll explain. I don't want to study back all these things because I have already studied and I have. I'm going to explain directly here. See, this is a diagram for phasor representation of an alternating quantity. So till now we have seen only this part towards the right side, this part, right? So you have, this is a waveform, a sinusoidal waveform which is having for the x-axis is angle. Angle means it will be 0 degree, pi, pi by 2, 2 pi, 2 pi by 3. You used to measure, no? But here it is 0 degree, and when it comes here 90 degree, 180 degree, 270 degree, and it is 360 degree. So the x-axis indicate it is an angle, and y-axis I'm going to indicate it is a current parameter. Even you can take it for voltage also, but for explaining the concept of phasor representation, here in this particular thing they have taken the current one, the current as a parameter, y-axis. Now at time t is equals to 0, when theta is equals to 0, theta is equals to 0 means what? Theta is equals to 0 means it is exactly at the origin. Okay, exactly at the origin. Okay, or instead of taking in terms of theta, or it in taking in terms of time period, I have just indicated as it is A, B, C, D, some alphabets. Okay, that is different instance in your sine wave. Okay, now I will consider at the position or at a point A. At a point A, at a point A, what is the projection across the y-axis? So what is the current it is present across point A? At point A, the current is 0. The current is 0. See, I'm just taking this theta. Theta is equals to angle A. At angle A, my current is 0. Okay, I'll go for B. I'll go for B. Okay, so if I go for B, what is my current? My current, some amount of current is it is present here. Okay, some amount of alternating current it is present here. And if you want to find out what is the length of phasor diagram which is flowing across the maximum value of an alternating quantity, if you want to find out this, so always I have the current equation, I is equals to Im sin theta. I is equals to Im sin theta. Now what I will just indicate one point here. Next, at instant C, I'm going to get some current, and at the instantly I'm going to get some points. Assume that this waveform it is not there at all. Okay, I'm just putting the points here, and now what I will do, from instant A I will join, and I'm going to get the sinusoidal waveform. This is my waveform. Now if I want to convert this waveform into a graphical representation or a phasor representation, always whenever you consider the phasor representation, always my angle it will move in the anti-clockwise direction. You consider it is going to move in the anti-clockwise direction. Assume this is a clock. If the clock, if it is moving from C to B, B to A means it is clockwise direction. Clockwise. If it is moving in the opposite direction from A to B, B to C, D, E, F, this is called as anti-clockwise direction. See, always whenever you consider the phasor diagram, it should move from in the anti-clockwise direction. So what I will do, at instant A, as my current is 0 and my angle is 0, so I will take it as my reference plane. So I will take one center point, I will draw one arrow mark here. So this is called as X. This is X. This is nothing but I can't indicate it is theta or current here in the phasor diagram. In the phasor diagram, I'll be having two axes. One is X axis and one more is Y axis. Okay, so if my current is 0 and the angle is 0 means it is going to coincidence with the phasor angle here. It is going to coincidence on the reference plane. Now at instant B, what is the current here? I will draw same what is that, I will project this, and I'm going to get one particular point here. So always my angle of rotation, it is going to take place in the anti-clockwise direction. So as the sine wave, it is increasing gradually and it goes to maximum. Similarly, the phasor also, it will go in this particular direction and it goes to maximum value. It goes to maximum value. At point C, you can see at point C, the y-axis projection is OC, from O to C. What is the value for O to C? That is nothing but a maximum amount of current that is flowing across your sine wave. Okay, that is the entire length of the phasor. Okay, this is my maximum current. If you measure in the phasor diagram, if I measure from 0 to T, I am going to get the maximum current. I'm going to get the maximum current. So from 0 to E is nothing but my maximum current. Even here in the waveform, you are going to measure from here to this particular point now. So maximum current. So this is nothing but my maximum current. Gradually from C to D. So from C to D. Again, I'll go from C to D position. My current is here. I will draw the same projection and it is going to meet at D. It is going to meet at D here. At this D, similarly at point D, the y-axis projection becomes Im sin theta. See, what is the instantaneous value of current? I is equals to Im sin theta. Im sin theta. So here I is equals to Im sin theta, where I don't have a maximum current at all here. So I will be equal to 0. So just use a formula, that's it. In the waveform, I have I is equals to Im sin theta. Im sin theta, this is known to you. This is known to you, right? And theta you keep it as it is. So what is Im initially at point A? This is 0. So the theta is also 0 here. Even though this is 0 here, so the current will be equal to 0. The current will be equal to 0. What is that value for sin 90? Can anyone just tell me what is sin 90?
1.
One.
Sin 90
One.
is 1, right? So if sin 90 is 1 means see here at point C, what is my current? It is maximum current. And what is the angle here? Theta. If I'm varying from 0 in this particular direction, it will
90.
be 90 degree, right? It is 90 degree. So if I apply this here in this formula, I is equals to Im. Now Im, it won't be 0 here because it will be maximum. I will take Im itself. And in place of theta, I'll put it as 90 degree. Okay. Sin 90 is 1. Sin 90 is 1. So I is equals to Im. I is equals to Im. So see here, I is equals to Im. So the maximum current, it will be present. The maximum current will be present. And suppose if I take at point D, if I take at some point D, okay, or if you want to explain me at point B, what is my angle here? I don't know the exact angle, but assume it as 45 degree. What is sin 45?
1 by root 2.
1 by root.
It is 1 by root 2.
0.707.
Yeah, it's 1 by root 2.
0.707.
No, I don't want the value. I'll just take like this. Okay. So I will take it as it is. I is equals to Im. Im sin theta. In place of theta, I will put it as 45 degree. I will put it as 40 degree. Just for an example, I'm taking 45. In the diagram, it won't be exactly 45 also. It may be some angle. Okay. Sin 45 is 1 by root 2. So what is my instantaneous current? It will be Im, it won't be 0 here at point B. Whether Im will be 0 at point B, no. Some amount of current is present. But this is not a maximum current. Okay. This is 90 degree. If I'm getting maximum current, means obviously at exactly half of this 45 degree, it should be Im divided by root 2. So that is the same current it is present here. So the same wave, the waveform, the sinusoidal waveform. So I'm going to vary the theta. When I come back to D here. So 90 plus 45, you just add up. So at some particular point, the waveform, it will go in a circular fashion and it will come back to 0. So if I want to if I want to put this sinusoidal waveform into the graphical representation, always move in the anti-clockwise direction. If you're moving in the anti-clockwise direction, you take the angle as positive. You take the angle as positive. Suppose if I'm moving from A to B, it is plus theta. If I'm moving from A to H, it is minus theta. If it is 45 degree means I will take it is for plus 45 degree on the top. And if you're moving from A to H, then take it as minus 45 degree. Okay. Always my phasor representation, it will move from anti-clockwise direction. And one cycle, if I'm completing one particular cycle, then a 360 degree rotation of the phasor representation will be completed for one particular cycle. See, I'm starting from 0, 180, 360. So by the completion of sine wave to 360 degree, I am going to complete one particular rotation with 360 degree in the graphical representation. Are you able to understand or not? Because this phase angle, understanding this concept is very important because you are going to use this phase angle further in your modules. Are you able to understand this? Yes.
Yes, ma'am.
Yes. Now I have taken theta here. It is in degrees. Suppose if I want to put it in radians, I will just replace theta is equals to omega into t. Omega is nothing but 2 pi f. So 2 pi f into t. You can indicate terms of omega also. If you want, you can indicate even in terms of radians per second, if not in degrees. The radians per second, whatever, if you are converting theta to radians or radians to theta, what is that, degrees, no matters. The phasor representation, it retains same there. But only when you are calculating in the calculators, you should make sure that if you are using a sine component and if it is in the terms of radians, please use it in the radians mode. If it is, use it in the radians mode. And if it is in the degrees, please use it in the degree mode. Sine 45 degree, then you can use it in a degree mode only. If it is sine 2 pi, then you should use it in a radians mode. Getting my point? So the next one is the next concept is nothing but you have understand what is phasor representation. Okay, how we are going to represent an alternating quantity which is shown in a sinusoidal wave. Okay, that we are converting back to a phasor representation. Now we are going to understand what you mean by phase. What do you mean by phase of an alternating quantity? Okay, what do you mean by phase of an alternating quantity? Now, if you want to understand the phase, a phase of an alternating quantity at any given instant of time, that is, at any given instant, is an angle phi which is traveled by a phasor representation with an alternating quantity up to an instant of consideration. For the reference, see, if I read this definition, you might feel you are not able to understand anything. But I will tell you here. I will tell you here. See, just now I have given you one particular problem where you have to remember that one symbol. One symbol. Just now in the class I have told you. You got some equation, something like when I am explaining about the current, you got something like that is sine omega t plus phi. So, you got this. This phi is nothing but my phase angle. This phi is nothing but my phase angle. Okay. So this phase angle I'm going to tell you now. This phase angle I'm going to tell you now. Okay. So this is nothing but phase angle phi. If I take this particular diagram, see. Okay. Now, as you know that if I start my what is that sinusoidal waveform, it will start from zero and it will start moving up. It will start moving. If I go exactly, if I take on the maximum current, that will be pi by 2. I know this value. I know it is 0. This is pi by 2. This is pi, and exactly here it will be 2 pi by 3, and this will be 2 pi. So if I'm taking with the zero count, I can have the value. And if I'm measuring the maximum current, I know direct values here. But at any instant B, I should measure the phase angle at instant B now. If I want to measure the phase angle at instant B, how we are going to measure? How we are going to measure? I will just take that phase angle as that the difference from O to B. This is a reference. This is O. From O to B, my phase angle is phi. I have taken. Okay, writing 0 and putting one perpendicular line is nothing but phi there. Okay, so the angle between 0 to B is nothing but phi. Okay, this is my phi. Now let us consider the x-axis. I will just consider this x-axis, whatever you are now. Now this x-axis, that is nothing but one particular reference. It is in terms of theta, and the y-axis I'm going to consider, that is my current. That is my current. Now, if my angle phi is 0, I will take a different instance here. Different instance here. Okay. Okay. I will take a different instance here. If my angle phi is equals to 0, phi is equals to 0, what is the current? What is the current when angle phi is equals to 0? When
0.
phi is equals to 0,
0.
it should be, the current should be 0. You can see here in the waveform only, you can see here this is 0 here. Eh? Okay, when phi is equals to 0, when phi is equals to 0 degree, then my current is also 0. And can anyone just tell me what happens when angle phi is equals to, if it is positive, suppose at the time t is equals to, at the time t is equals to 0 only, at time t is equals to 0, if my phase angle is positive, if my phase angle is positive, okay, it is something like I can indicate something like this. 1 second, I will just draw and I will show you here. See, assume that So I have a waveform here. Okay, I have a waveform here. At time t is equals to 0 only, I'm going to consider this is my either it can be taken as a with respect to time, and this is my voltage or current. I will indicate either it is voltage or current, any of the equation, voltage or current. And now am going to take what is my phasor representation or phase angle for a given quantity. Okay, for a given quantity. Now I am going to consider what is the phase angle when time t is equals to 0. When time t is equals to 0, my current or voltage is 0 here. My current or voltage is 0 here. Current or voltage is 0. So whenever I'm taking this angle 5, see, you don't confuse with the theta, and don't confuse with the theta and angle 5. Theta and angle 5. If I am introducing a phase angle, if I'm introducing the phase angle, that is a phase angle 5 of an alternating quantity, and this phase angle also it can vary from 0 to 2 pi, or if it is in radians. If it is degrees means the phase angle it can be varied from 0 to 360 degree. 360 degree. So if I want to write the general equation by including the phase angle concept, so my equation for current voltage will be, this is my instantaneous value of voltage, E is equals to Em sin omega t. This it is known to you, right? Em sin omega t. Sin, don't don't put this bracket. It is Em into sin omega t. So this is a general equation that you have calculated without phase angle. Without phase angle, it means the phase angle was 0 completely, without any difference in the phase angle. Now if the phase angle comes into picture, if the phase angle comes into
Omega
picture,
t plus
then I'm
5.
going to add, a plus 5 here, plus 5 here. So this is my phase angle which will be added to the voltage, which will be added to the voltage. So see, this is omega t is nothing but my theta. This omega t is nothing but my theta. So your general equation for E is nothing but Em sin theta you used to write. Now this is theta is an angle. Theta is an angle which is measured in the degrees. So this is not a phase angle difference. Now if you want to understand the phase angle concept, this phi will be added up. This phi will be added up. And this phi, the angle phi, it can vary from 0 degree to 360 degree. I can vary this angle phi from 0 to 360 degree in degrees, or I can vary from 0 to 2 pi in radians. In radians. In radians. Now my point is, you take the same equation. You take the same equation. This equation only. The general equation. Whenever you come out with the addition of phase angle, it will be E is equals to Em sin theta. This it is known to you. Em sin theta plus 5, or if I want to indicate in terms of omega t, I can put even it is in terms of omega t plus 5. Omega t plus 5. Now I will consider initially my first case. I am going to consider phi is equals to 0. Phi is equals to 0 degree. If I consider phi is equals to 0 degree, what is my equation? The final equation, E will be equal to Em sin omega t, because this phi is 0. This phi is 0. So when I understand this, when phase angle is 0, so when I write the sine wave here, if my at instant t is equals to 0, if my phase angle is 0, then my waveform it will start from 0 only. Then the sine wave it is going to take like this. Means I don't have any phase angle difference here. This is my first condition. Okay, at time t is equals to 0. And I'm going to show you the phasor diagram. This is just a, what is it, a waveform. This is just a waveform that I'm showing with respect to the time versus a voltage or current. This is a voltage or current. Okay, if my phase angle is 0, my waveform it will start from 0 itself. It will start from 0. Just keep this concept in mind. If my phase angle is 0, my waveform it will start from 0 itself. Suppose if my phase angle is positive, phase angle is positive, either I can take any in place of 5 I will put it as plus 5. Okay, plus 5. So plus 5 means what is that? At an angle. So instead of taking my voltage here, what happens? I'm maintaining some angle phi here. I'm maintaining some angle phi here. So if I'm maintaining the angle phi, that is when t is equals to 0. I'm not maintaining at here. So at the time t is equals to 0, I'm maintaining some phase angle, means instead of starting from 0, my waveform, it is going to start. It is going to start from the positive. See, the angle phi. The angle phi, it is there no somewhere. Due to that angle phi, my waveform, it will start here. It will start in this direction. It will go and it will come back in this particular direction. So my phase angle, it is not starting at t is equals to 0 when the phase angle is positive in nature. When it is positive in nature. Positive in nature. And suppose if my phase angle is negative, if my phase angle is negative, means that is minus 5. My waveform, it will start from negative. When time t is equals to 0, when time t is equals to 0, my waveform somewhere it is going to start from here. It will start from negative. From here it will go to maximum and it will come back in this particular direction. This particular direction. So this is for phase angle 0, this is for positive phase angle, and this is for negative phase angle. Negative phase angle. Okay. Now, as I said you, always the phase angle, we are going to take it from the anti-clockwise direction. Okay. If I want to show the phasor representation, see, here is the phasor representation. Here is the here is the phasor representation. See, when I consider my phase angle phi is equals to 0, my equation will be E is equals to em sin omega t. Plus 5, it will be 0 here. Okay. So when I get this maximum voltage, always at the time t is equals to 0, my current, it will, the voltage, it will start exactly at 0 because my phase angle is 0, and I'm going to get a waveform like this. If I want to write this, waveform into the phasor representation, so what is my phase angle? My phase angle is 0, no? So my arrow mark, it will be indicated like this. Arrow mark, it will be indicated. See this arrow mark, the line with the outward arrow mark, this is the representation of a phase angle. This is the representation of phase angle. Okay. Now the second is, as I told you, my general equation whenever writing E is equals to m sin omega t, if I am including the phase angle, the positive phase angle, my value will be omega t plus phi. Omega t plus phi. So plus phi, it should be added. I have E is equals to m sin omega t. I got E is equals to m sin omega t. I got a straight line on the reference. For this particular one, if I add a phase angle plus 5 means always it will move in the anti-clockwise direction. No, it will move in the anti-clockwise direction. So if I add for that particular line which was there in the reference, if I add plus 5, so that particular line, it will be shifted with an angle of plus 5 here. So this is a phasor diagram of positive phase. If you have the positive phase, see my waveform, it will start when time t is equals to 0. As it is a positive phase angle, so my value, it will start from here. Okay. And for the during negative phase angle, so minus 5 you have. As I told you, the phase angle, it will be indicated in the anti-clockwise direction. If you're moving, means it is positive. If you're moving in the clockwise direction, it should be considered as negative. So it is minus 5 means it is opposite direction. So instead of taking the reference plane on the above, I will come back in this particular direction. See the direction here, it is downwards. So this is a phasor diagram of your negative phase. This is a concept of phase angle. This is a concept of your phase angle. Getting my point? Getting my point? See, keep this, what is that? Keep this points in the remembrance, and try to study the concept which is already given, which is already shared to you. The materials are already shared to you. Study the theory part, whatever I have, what is that? It is shared already. Okay, when you study this and when you analyze with the diagram, you can easily understand. Even if you have a little small doubts also, it will be clarified there itself. Getting any doubts? Any doubts here with the phase angle? I'll just quickly take with the attendance. I think I'm running out with the